The title of today's presentation is Introduction to Statistical Analysis using Microsoft Excel. This presentation is prepared to enable students to be able to recall the important point discussed during the physical classroom lectures. The objectives of the presentation include: 1. Introduction to Excel basics. 2. Data entry. 3. Analyzing data. Then formulas and functions for descriptive statistics. Number 5, representing data graphically as bar chart, histogram, pie chart, etc. And lastly, correlations and scatter plots. Now, starting with the first category, which is Introduction to Excel Basics. A typical Excel user interface looks like this. On it, it contains the quick access toolbar. Quick access toolbar is located at the top left corner. Usually it contains icons for frequently used features such as print, preview, save options, etc. There is also file tab, which opens menus for opening and saving files and modifying Excel options, etc. It also have the home ribbon, which can be regarded as the top header of the Excel. Now, in the home ribbons, there are several tabs that are used to change font size, for example, justify text, insert rows, etc. The ribbons are organized in groups of similar tasks, such as the font group that are used for changing font types, or the number groups that are used for numbering, formatting. And in addition, there are other ribbons containing groups or buttons for laying out pages, using the review features, formula, etc. Now, below the home ribbon is the Excel sheet, which contain columns and rows that are used to impute data into the Excel. Hence, the spreadsheet is used to organize information, text, and numbers by rows and column. Let's take a look of it. This is a row. Rows are represented by numbers along the side of the sheet, and this is a column. Columns are represented by letters across the top of the sheet. This makes up the Excel sheet, rows and columns. Now, Excel sheet is made up of several small boxes, which are made up of the intersection between rows and columns. These small boxes are called cells. That is, a cell is the intersection between a column and a row. As a result, each cell in Excel is named for the column letter and row number that intersect to make it. In this example, we have cell B2, which is made up by intersection between column B and row number 2. Hence, it can be regarded as cell B2. Now, here is an example of a typical Excel sheet showing cells containing data. When you look at it, we have the rows that are arranged in numbers, and we have columns that are arranged in that are arranged in alphabets. Now, this takes us to a spreadsheet. As mentioned earlier, spreadsheet is an electronic sheet organized by rows and columns that are used to record and organize data. Here is an example of a spreadsheet containing a data. The advantage of electronic spreadsheet is that it allows you to easily change data and have all related calculations automatically updated. Now, apart from worksheet, we also have what is called an Excel workbook. Excel workbook is an Excel file that contains one or more Excel worksheets. Here is a typical Excel workbook which contains several Excel sheets that are numbered sheet 1, sheet 2, sheet 3. And each of these Excel sheets can be renamed by right-clicking on the existing tab and selecting the rename option. In addition, the Excel workbook contains several tabs and functions such as the quick access toolbar and file tabs, which we have seen previously. There is also the sizing buttons, which are used for maximizing, expanding, minimizing, or closing the Excel sheet. At the bottom right, there are view buttons, which are used to change the view of the Excel sheet. And there is also zoom button, which can be used to zoom in or zoom out the Excel sheets. In addition, there are also vertical and horizontal scrolling bars, which are used to scroll the Excel sheets vertically or horizontally, respectively. Now, others include row numbers and column letter headings, as we described previously. There is also the fx function, which is insert function button. The fx insert function button is used for inserting formulas into the formula bar. In addition, we have the formula bar, which display formulas and content of active cells. Lastly, there is what is called an active cell. An active cell displays the formulas and content is a selected cell that display the formulas in the formula bar. And lastly, there is a name box that display the name of the active cell. So altogether, this makes up what is called an Excel workbook. We are going to see how we use this in the subsequent slides. Now, as a recap of what we have seen under the Excel basics, here is a list of some Excel definitions. We have workbook, which is an Excel file with one or more Excel worksheets or pages. Then we have the worksheet itself, which is a page in the workbook. Then we have the ribbon, which are the tabbed section containing commands and icons. We have row, which is a horizontal lines in the Excel worksheet, which are represented by numbers. We also have column, which are vertical lines that are represented by letters. We have a cell, which is an intersection between column and row. Then we have values, which are numeric entries that are used in calculation. We have labels, which are text that describes the data. We have active cell, which is a cell that is currently in use or highlighted. And lastly, we have the formula bar, which is at the top of a spreadsheet where Excel displays the value or formula for an active cell. Now, having briefly introduces the Excel basics, let us look at the second aspect of this presentation, which is data entry. There are two ways to enter information into an Excel cell. The first one is to type directly into the cell. To do this, click on the cell, type in the data you want to impute, either numbers or text or whatever, then press enter. The second method of data entry is to type into the formula bar. To do this, click on a cell, then click in the formula bar, the space next to the f of x. Now type the data into the bar and press enter. So these two methods are used for typing or imputing data into an Excel sheet. Now, as an exercise on data entry, let us open our Excel file. To do this, click on the Start menu of the computer, then select All Programs, select MS Office, and click on Excel. When it opens, enter the following information into the spreadsheet using any of the two methods of data entry. Having learned about data entry into an Excel, let us briefly introduce Excel formulas and functions. A formula is an equation that performs calculation in the Excel spreadsheet. Formulas always begin with an equal sign. When you enter an equal sign into a cell, what is mean is that you are basically telling Excel to calculate this. That is why all formulas start with an equal sign. In addition, formulas contain two types of components: operators, which represent the operations to be performed. For example, arithmetic operators such as multiplication, division, addition, subtraction, and so on. It can also be relational operators such as greater than, less than or equal to, greater than or equal to, and so on. While the second component of a formula is operands to values to be operated on. For example, in this example, we have equal sign followed by B2 plus 5. As we said, each Excel formula starts with an equal sign. By typing this into a cell, you are telling the Excel to add cell B2 plus 5. Now, in this example, the addition sign is the operator, while cell B2 and B5 are the operands. In addition, a formula can also contain built-in functions, built-in Excel functions like sum, average, if, count if, and so on. Built-in functions are generally Excel-defined formulas that take entered or selected data, perform calculations on it, and return values. Now, still on functions, which we define as Excel built-in formulas, all functions have a common format. They start with equal sign, followed by the function name, either average, sum, and so on, then followed by the input in parentheses. Now, the input for a function can either be a set of numbers. For example, if we type equal to average bracket 1, 2, 3, 4, 5, the equal sign, the average is the function, while the numbers in parentheses 2, 3, 4, 5 are the input. By typing this into an Excel, it tells the Excel to calculate the average of these numbers. Now, input can also be referenced to Excel cells. For example, we can type equal to average B1 column B18, or if we want to separate it, we can type average in bracket B1, comma B2, B3, B4, B5, B6, B7, B8. By writing this in an Excel cell, we are telling the Excel to calculate the average of the data that appear in all the cells from B1 to B8. Now, in order to use a reference to a cell to write reference to a cell, you can either type equal to followed by the function, and then you type in the reference cells, or by clicking and dragging the mouse to select the desired cells. Now, let us look at the common functions that are used for Excel descriptive statistics in Excel. For example, if we want to calculate the mean of a data, all we need to do is to write equal sign average. The average represents the function for calculating mean. So we write equal sign average, then in the parentheses we write the first cell, column, last cell. That is the first cell where the data start, and then the last cell where the data stop. By writing this, we are telling the Excel to calculate the mean from the first cell to the last cell. Similarly, if we want to calculate the median, we write equal sign median, then in parentheses we put the input first cell to last cell. This tells the Excel to calculate the median of the data from the first cell we select to the last cell. Similarly, for mode, we write mode equal sign mode, then the input first cell to last cell. This tells Excel to calculate the mode, and so on. Now, to write functions for descriptive statistics, you can either directly type the functions in a cell or in the formula bar, just as we described for a method of data entry into the Excel, or you can decide to use the function wizard we introduced previously, which has f of x. By clicking on the function wizard, you can now select the appropriate function you want to perform. The function f of x contain the Excel built-in functions such as the average, median, mode, whatever, standard deviation, and so on. So when you click on the wizard function, you can now scroll down to select the appropriate function you want to perform. Now, if we apply the functions in the previous slides on our previous practice Excel sheet, we will be able to have something like this. We will have the mean, median, mode, variance, and standard deviation of the data. Now, having briefly discussed the Excel formulas, let us quickly look at statistical chart. That is how to draw statistical chart using an Excel. How to convert Excel data into charts. Now, to convert Excel data into a chart is very simple. The first step is to highlight the data, then click on Insert Tool in the toolbar, then select the chart type you want, then edit if you need to edit anything, and then you click and it's done. For example, in this example, we have antibiotic A and antibiotic B. To produce a chart using this data, we can now select the two columns for antibiotic A and antibiotic B. Then we click on the insert button in the Excel. After clicking the insert buttons, it will display the following information. Now, if we select column chart, it will show various columns which we can select to represent this data. If we decide to select a column chart, our data will now look like this. So when you look at it, we have antibiotic A and B selected, and then by selecting column chart, we have the output represented in columns. Similarly, if we decide to select pie chart, for example, then our chart will look something like this. There are several other options which you can explore on the chart type and so on. Some of the options we can explore, for example, we can decide to change the chart type or switch the rows and column. In order to do this, we simply click on the chart, then click on the chart tool, then click on the design, and then from there we can change the chart type, or we can click on the switch row and column directly. There is switch row and column that is displayed. We can click on it directly, and we are going to have a new data generated with columns and rows being switched. We can also decide to add some chart element. For example, we can decide to insert chart title, axis labels, legends, and so on. To do this, all we need to do is to click on the chart. After clicking on the chart, we now select the chart tool. When we click on the chart tool, we click on the layout. When we click on the layout, we now select chart title. So when we click on the chart title, we can be able to edit the name of the chart title with the desired name we want, and then we click OK. For example, in this case, we can edit the title as activity of antibiotic A and B. We can also edit the axis title, which is this one, by selecting the axis title here and then writing the desired name we want. For example, in this case, we can write antibiotic. We can also decide to change the axis title, which is this one, the vertical title. Now to change the axis title, we select the axis title here and then we edit it. Like in this case, we can say activity. So activity of antibiotic A and antibiotic B. So these are several options we can use on Excel charts. In fact, we can also create an Excel chart even by selecting columns from multiple data entry, not necessarily columns that are close to each other. For example, when you look at this data, we can decide to select column A, for example, which is food items, and make a chart between the food items column and, let's say, column D, which is the total price per food items. So to do this, we highlight column A and column D, then select insert chart, and then we select a column bar chart. When we select column bar chart, we'll have something like this. We'll have the prices at the vertical axis and the food items on the horizontal axis. Now, it should be noted that statistical analysis in Excel are not limited to descriptive statistics. In fact, Excel comes with a statistical tool package. This statistical tool package contains many statistical functions. In fact, there are several statistical tests and analysis that requires the use of statistical tool package. And therefore, in order to do this kind of test, we need to install the statistical tool package. In order to install the statistical tool package, we click on the File option in the Excel. Then we click Add-ins. Then we select Statistical Tool Package. Once we select it, we click OK. By clicking OK, the statistical tool package will now be added to our Excel home page. Now, the Excel statistical tool package or data analysis tool contains several statistical analysis. It can be used for several statistical tests such as correlation analysis, regression, ANOVA. In fact, it also has the descriptive statistics functionality. For example, let's say we have a score variables and we want to perform descriptive statistics on the score variable. So all we need to do is to click on data analysis on our Excel home tab. That is, we click on the data analysis tool. When we click on the data analysis tool, we now select descriptive statistics. Once we click descriptive statistics, a window will open. A pop-up window will open. Then in the pop-up window, we now highlight the columns containing the scores, we want to check their descriptive statistics, and then we now we now select summary statistics. There is summary statistics below. So we now select summary statistics, and then after clicking summary statistics, we now click OK. Once we click OK, we'll now be able to see the complete descriptive of our data. So this is it. Once we select descriptive, once we click OK, our table will now look like this. So with lot of information, including the mean, standard error, mode, it will calculate all the descriptive statistics for that particular column. Now, let us briefly look at correlations. Correlations are statistical analysis that can be used to determine the relationship between two variables. Now, every correlation has a direction, either positive or negative direction. Positive correlation indicates that the high score on one variable are associated with high scores on another variable. While if we obtain negative correlation, it means that the high scores on one variable is associated with low scores on another variable. In addition, correlations also have magnitude or strength. The magnitude tells the strength of the relationship. For example, the closer the relationship, the closer the correlation coefficient to plus 1.00 or minus 1.00, the stronger the relationship between the variables, whether negative relationship or positive relationship. While the closer the correlation coefficient is to 0.00, the weaker the relationship, whether positive correlation or negative correlation. Now, let us look at specific example, calculating Pearson's correlation R. Correlations are described using the Pearson product moment correlation statistics, or the R value. In Excel, there are many functions that can be used to calculate a correlation statistics. However, we will only use Pearson correlations in this presentation. Let's say we want to determine if there is a relationship between number of study hours spent per week studying MCB microbiology and final grade point average GPA earned by the student in the class at the end of a semester or a quarter. Now, to do so, we can calculate the Pearson's correlation for the two variables, that is study hours versus the GPA scores. Now, first, we need to open our Excel, then type in the study hours and average GPA. Study hours, average number of hours spent per week studying microbiology, and the grade point average earned in microbiology at the end of the quarter. Once we do that, we can now move ahead with the correlation analysis. Now, to determine the R value, we now following steps. Step number one, we first of all select the cell where we want the R value to appear. After selecting the cell, we now click on the f of x function. When we click on the f of x function bottom, it will show a drop down, and then we search for and select Pearson correlation. Once we search Pearson correlation, we click OK. By clicking OK, a pop-up window will appear which shows RA1 and RA2. So in RA1, we click on RA1 and select all values under study hours. And click on RA2 and select all the values under GPA. Then we click OK. That is it. Once we click OK, our R square value, our R value, the correlation will now show in our selected cell. In this case, the R value is shown as 0.88. That's study hour versus GPA. Now, let's have a quick knowledge check. What does the R value of 0.88 tells us about the strength and direction of the correlation between study hours and GPA? Remember, we said we have positive correlation in which and negative correlation. A positive correlation tells a direct proportion between the two variables. When the first variable increases, the second one increases. And we have negative correlation, which is reverse of the two. So having 0.88 as our R value, it tells us that the relationship between study hours and GPA is positive. That is, the higher the study hours, the higher will be the GPA. In addition, when you look at it, 0.88 is close to 1. So being close to 1 means that the relationship is strong. So we can say there is strong positive correlation between study hours and GPA. So this is how we interpret correlation result. Now, another way to display the correlation between visually the correlation between our variables is to use scatterplot. Scatterplot is an excellent way to visually display the relationship between two variables. Each point on the scatterplot represents an individual's data on the two variables. So now let us create a scatterplot for study hours and now the first step is that we select both columns of the variables we wish to plot, that is study hours and GPA. Then we click on the insert tab. Remember, when we want to create chart, we have to click on the insert tab. So when we click on the insert tab, now select scatter chart. So once we select scatter chart, have options that will display. So we now select the first plot in the drop down menu. So when we select the first plot in the menu, we'll now have something like this as our scatter plot between study hours and GPA. So next, we now try to add the axis title. We just follow the previous description on how to add axis title by clicking on the chart tool, layout, then selecting the axis title. Once we select the axis title, we can now be able to edit the axis. Now there are some points to remember. For a scatter plot, it does not matter which variable goes on each axis. This is not true for other types of charts. However, you need to make sure you label your axis with the proper variable name. In this example, GPA is on the y-axis and study hours on the x-axis. We can tell this based on their different ranges or values. So as a helpful hint, Excel will automatically put the first variable left hand in the left hand column on the x-axis, while the second variable, which is in the right hand column on the y-axis. So we should take note whichever column we want to appear as vertical or horizontal column. We should remember the left hand and right hand column rule of the. And now look at our chart. We can change the chart title, as we said, the axis title. So by changing it, our scatter plot is now finished. Now, a point to remember, each point in the scatter plot represents an individual's data. So identify student number 8 in the scatter plot. This is a quick as a class activity. So to conclude, in describing correlations and scatter plot, we shall take note that scatter plot and correlations are described as positive or negative, as weak, moderate, or strong, and using the R-square R value. For example, in our previous example, we can put the first sentence to describe the relationship between study hours and GPA as that there is a strong positive correlation between the number of study hours and GPA. Then, if we want to describe the general relationship between the two variables, we can add the second sentence. That is to say, more study hours or more hours of studying MCB was associated with higher GPA earned in the class at the end of the semester or quarter. It should also be noted that we cannot say more studying lead to higher GPA. This implies causation, so which cannot be determined using correlational research. Now, this takes us to the end of this presentation, and thank you for listening.